Ogni Media Vision.
Hello viewers, I am Chamok. Welcome to Three Phase Academy. So today we are going to start another new lecture on current divider rule. So we will learn how current divide in the circuit. So what kind of circuit? So we know there are two types of circuit: series circuit, parallel circuit. So in series circuit, what happens? The current remains constant, but the voltage changes. But in parallel circuit, the current divide keeping the voltage constant. Now let us draw the parallel circuit. This is a current source, and there is only two branches over there. So this is I, R1 and R2. But we know for parallel circuit the voltage remains constant. So for the source there will be V, and for R1 there will be V1, and for R2 there will be V2. So this is V, V1 and V2. That means V equal to V1 equal to V2. But from Ohm's law we know V equal to IR. That means we can write from this equation like V equal to V1 and also V equal to V2. So this is actually the same. Now if we apply the Ohm's law, we'll find V equal to IR. But the question arises, why there is R? Because we are supplying only the current source, right? Because no source can't be without internal resistance. So why there will be an internal resistance? If there was no internal resistance, so what will happen? Infinite current will flow through the circuit. But that is not possible in our real life. So there will be an internal resistance in between the sources. Now we can write this I1 and R1. Now we can find I1 from this equation. So what we get? I1 equal to IR by R1. This is the total resistance. So we know for a parallel circuit the total resistance is equal to RT equal to R1 into R2 divided by R1 plus R2. If we plot this equation over here, so what we will get? I by R1 into R1 into R2 R1 plus R2. So the net result is IR2 divided by R1 plus R2. Similarly, we can find the equation for I2. So for I2, we will get the same result. What? That is I into R1 plus R1 plus R2. That means for the both equation we get so this is it. This is the equation for current divider rule. Now we will see the mathematical application on this current divider rule. So let us consider the current source is 20 ampere. That means 20 ampere, and the and the resistance is 5 ohm, and the resistance for R2 might be 3 ohm. Okay, so what we will get for this I2 equation and I1 equation? So let us plot. So for I1, the value will be 7.5 ampere. Similarly for I2, we can write I2 equal to 20 into 5 plus 5 plus 3. That will be... Now we have to check the total current is equal to I1 plus I2. So we know I total equal to I1 plus I2. That means 7.5 plus 12.5 is equal to 20 ampere. This result and this result is same. So it verify the current divider rule. So viewers, we have proved the current divider rule with mathematical expression and with equation. So if you have any queries, any questions about this lecture, so please comment below and help us know what problem you are facing right now. So we'll try to solve it in future. Thank you very much.